Hello students. So in our previous class, there is a previous video class, we discussed about balance equation and writing the physical state of a chemical equation. Okay. And this particular equation I gave you as homework. Clear? But many of you have asked me to share or discuss how it is done. So now look at the equation. Here 3 calcium here and the number of calcium in the product side is only 1. Okay. So we have to balance it. Here we have 3, here we have 1. So what will give here? 3. Okay. So now look at nitrite. We have 2 nitrogen here and only 1 here. Okay. So now what we look at? If we look at this portion, here we have only 1 nitrogen, here we have 2 nitrogen. Okay. So if we can balance it by using by what? By 2. Okay. So as soon as we balance this by 2, now the number of potassium is 2 into 3, 6. But here we have only 1 potassium. So how can we balance it? By using 6. Okay. So we will write 6 here. So once we write 6 here, so now the number of nitrate. Okay. So this as a whole NO3. We are considering NO3 as 1 unit. Okay. So as a whole nitrate now is 6 on the reactant side, and on the product side also we have 6 because 2 into 3, 6. Okay. So number of nitrate is also 6. So if you look at this, you can see that the number of each element is balanced. Okay. So if you look calcium, we have 3, here 3, nitrogen, here 2, here 2, potassium, here 6, here 2 into 3, 6. Okay. Next, if we look at it, nitrate as a whole, so number of nitrate is 6, here also number of nitrate is 6. And if you want to consider separately that nitrate consists of nitrogen and oxygen. So if you consider both nitrogen and oxygen separately, then also you can see that this equation is now balanced. Now, so if we are looking separately at nitrogen and oxygen, you can see here nitrogen is 2, here nitrogen is 6. 2 plus 6, 8. Okay, here nitrogen 2, and here nitrogen 2 into 3, 6. Okay, so here nitrogen is 2 from here and 6 from this side. Okay, equals to 8. And here 2 here and here 3 into 2. 3 into 2. The number of nitrogen will become 8. So nitrogen is balanced. Now look at oxygen. So number of oxygen here 3 into 6. Okay, 3 into 6, 18. Now look at number of oxygen here. 3 into 2, 6, 6 into 3, 18. So 3 into 3 into 2. This is also equals to 18. Okay. And potassium is also balanced. Here potassium 2 into 3, 6, here 6. Okay. So each of the element has similar number of atoms both on the reactant and product side. So now we can say that this particular chemical equation is balanced. Okay. So now we are going to our next chapter, that is types of chemical reaction. So before going on to the types of reaction, one important thing is that how can you determine that a chemical reaction is taking place? Suppose we are getting a beaker here, okay, and something is going on here, means it has some liquid or say some solid or some method in it. Okay. So now if anyone asks you that is any chemical reaction going on in this beaker, so how will you determine that a chemical reaction is taking place in the beaker? So generally we will look at these 4 observations. Okay. So we will try to see if the color of the metal present in the beaker changes. Okay. If the initial color was different and the color later on changes to a different color, then we can say that a chemical reaction is taking place in the beaker. Secondly, we can also see if the state changes. State changes means suppose initially we put a liquid on the beaker and later on after the reaction completes, if we find that any solid is obtained or a portion of the amount of substance that was present in the beaker changes to gas. Okay, then what we can say that state of the matter in the beaker it changes. Okay, again we can see that evolution of gas. In some reactions we will find that some gases are coming out of this, okay, after some time. So what we can say that gases are produced in the beaker. That means something chemical some chemical reaction is occurring in the beaker. So we can say that gas is evolving out of the beaker. Okay, so this is what evolution of gas means. Okay, and the fourth, what we can see that if temperature changes. Okay, so suppose when we are adding acid, any concentrated acid to water, if you touch the beaker, when we are doing this, we can feel that the temperature of the beaker increases. So what we can say that any chemical reaction is occurring on the beaker due to which the temperature of the beaker as a whole changes. Okay, it becomes more hotter. Okay, okay. So that means the temperature is increased. The initial temperature was less. Okay, but when the chemical reactions proceed, we can say that temperature changes. And in case of dilution of acid, that is when we add acid, strong acid to water, we will see that temperature increases. Okay, so these are the 4 observations that we generally make to determine whether a chemical reaction is taking place. Okay, so now let us go into the types of chemical reaction. So now let us look at types of chemical reaction. Okay, so the first reaction is combination reaction. Okay, so what is combination reaction? Look at this particular reaction. Okay, this is a symbolic reaction. That is, we have 2 reactants A and B. Okay, so 2 reactants A and B are reacting to form a single product, that is AB. Okay, so AB is one product. Okay, this AB is only a single product, and we have 2 reactants, that is A and B, and they are together combining to form AB. So what do we mean by combining? That is adding now. Okay, so in combination reaction what happens? That is two or more reactants form a single product. That is, we may have more number of reactants, that is 2, 3, okay, and they will add up together or they will combine together to form only a single product. Okay, so this is an example from your book. What is this? This is calcium oxide. This is water. This is calcium hydroxide, and heat is also produced. Okay, so now what we can see, as we have discussed earlier while writing the physical state, all metal oxides are present in their solid state. Okay, so we will write here as water is always in their liquid state. Water is in liquid state. Calcium hydroxide, again it is soluble in water, so we can write here aqueous. Okay, and heat. Clear? So we have written the physical state. Okay, now one more important thing that you have to know, we have some specific name for this and this. Okay, so calcium oxide is also known as quicklime. And calcium hydroxide is known as slaked lime. Okay, so quicklime and slaked lime. Okay, so these are their common names. Calcium oxide is known as quicklime and calcium hydroxide is known as slaked lime. So what we can see in this reaction, that calcium oxide is reacting with water, okay, to give calcium hydroxide. So 2 reactants, that is one is calcium oxide and one is water, is reacting to form calcium hydroxide. Okay, and in this process heat also evolves. That is, the temperature of the solution will increase. So we are telling that heat evolves. Okay, so this is one of the most important example given in your book. Okay, this reaction is also important for one another process, which is a very common question in your board exam. Okay, so before that we will be looking at 2-3 more example of combination reaction. So some other example of combination reaction is burning of coal. Okay, so generally all reactions that include burning are known as combustion reaction. Okay, combustion. So burning, all reactions that includes burning are known as combustion reaction. On combustion or in burning, what happens? We add oxygen to any other substance in presence of heat. Okay, So in burning of coal, so coal in coal we have carbon. Okay, so coal is consist of carbon. Okay, and in its solid form, and we have oxygen that is present in the atmosphere, and we heat it. Okay, so what we get? Carbon dioxide. Okay, so carbon is burnt in presence of oxygen to give carbon dioxide. So in this reaction, we are seeing that there are two reactants, okay, so that are combining together to form one product. Similarly, in formation of water, this is a very common example of common reaction. You all know that water is formed from gaseous hydrogen and gaseous oxygen. Okay, so hydrogen is present in its gaseous form, oxygen also present in its gaseous form. It gives water which is present in its liquid state. So here also hydrogen and oxygen gases are combining to form water. Okay, so if you balance this equation, you can write here 2 and here also 2. Okay, so these are some very common example of combination reaction. Okay, so now we will be looking at whitewashing of wall. Okay, so this is present as an yellow box in your above in the above portion of page number, top portion of page number 7. Okay, so there is a yellow box with DDU logo, and in that yellow box we are having about whitewashing of wall. So what is whitewashing of wall? So before painting in wall, generally a white layer is put in the walls so that it can be painted easily. Okay, so that process is known as whitewashing of wall, and it is one of the most common topics from where you will get question in board exam. Okay, so generally it is seen that in every alternate year a question from this part is common in your board exam. Okay, so whitewashing of what? So whitewashing of what we need? Calcium hydroxide solution, that is slackline solution. Okay, so we need calcium hydroxide solution here. So we cannot get calcium hydroxide solution directly. So how it is done? Generally this calcium hydroxide solution is produced from quicklime. So this is the example that we have already seen while we discussing the combination reaction, that is quicklime, that is calcium oxide, which is in its solid form, is reacted with water. Okay, so in quicklime water is poured. Okay, so it is made to dissolve in water. So what we will see, that there will be a reaction between quicklime and water, and slackline will be produced in its aqueous form. So we need calcium hydroxide as solution. Solution means calcium hydroxide in water. Okay, so whenever there is a solution, that is something is dissolved in some other liquid. Okay, so here calcium hydroxide should be dissolved in water. So aqueous all means that calcium hydroxide solution, calcium hydroxide is in its dissolved state in water. Means if anything is dissolved in water, we can write their state as aqueous. So here calcium hydroxide is formed as a solution in water. So this is the thing we require. Okay, so what happens once we get calcium hydroxide from this reaction, that is we are taking calcium oxide, solid calcium oxide, we are pouring it in water. Okay, so what we will get? We will get calcium hydroxide solution. Okay, so this calcium hydroxide solution is used for whitewashing. Okay, so once the whole wall is whitewashed, so this when we what will happen? We leave the wall, okay, to dry. So after 2 to 3 days, we will see that there is a shiny surface on the wall. Okay, white shiny surface on the wall. So after whitewashing the walls with calcium hydroxide solution, after 2 to 3 days, when you let it dry, then what will happen then? We will see white shiny surface on the walls. Okay, so why this white shiny surface forms on the wall? Because what we are whitewashing, when we're whitewashing, what we are using? Calcium hydroxide solution. Okay, so when we let it dry, so what will happen? That in the air we already have carbon dioxide gas. Okay, so this carbon dioxide gas will react with calcium hydroxide. Okay, so carbon dioxide gas will react with calcium hydroxide that is present on the walls. Since we have whitewashed the walls, so we are whitewashing with calcium hydroxide. So this calcium hydroxide will be present on the walls, and carbon dioxide is present in air. So these two will react, and what they will form? Calcium carbonate. Okay, so calcium carbonate is a solid salt of calcium. Okay, so calcium carbonate is a salt, and calcium carbonate is produced from this reaction. Okay, and this calcium carbonate gives the shiny surface of the wall. Okay, after whitewashing. So why the generally question is asked that why after whitewashing the wall we get a shiny surface when we let it to dry for 2 to 3 days. So why this shiny surface is obtained? So this can be your question. So your answer is that while whitewashing of wall we are using calcium hydroxide solution. Okay, and this calcium hydroxide is obtained from the reaction of quicklime with water. Okay, so once this wall is whitewashed with calcium hydroxide and when we let it dry, then the carbon dioxide present in the air can react with calcium hydroxide, okay, present in the walls. Okay, and they will form calcium carbonate, and this calcium carbonate, which is solid, gives the shiny surface of the wall. Okay, so while writing the answer, you also have to mention these two chemical equation. Okay, and this calcium carbonate, okay, this calcium carbonate, it is also the formula of marble. Okay, marble. Okay, so questions related to marble can also be asked. Okay, so if what question will be that when marble is heated, what can be formed? Okay, so that we will be looking at our next section of types of reaction, that is on decomposition reaction. We will be looking at calcium carbonate again. Okay, but just remember that marble, chemical formula of marble is calcium carbonate. Any question regarding marble, if it comes in your exam, we have to know that the question is on calcium carbonate. So again, on the basis of heat. Okay, so on the basis of heat, you can see that in some reactions, what we are discussing as an example of combination reaction, also you are seeing that in some reactions heat is produced when the reaction proceeds. Okay, so as the reaction occurs, we can see that heat is produced. Okay, and in some reaction you will find that we are supplying heat. Okay, means we have to heat the reactant so that the reaction proceed. So what we are saying, in some reactions we are giving heat to the reactant so that the reaction starts. Okay, and in some reaction what we are saying that even if we are not supplying any heat, but after the reactions complete, we see that temperature increases. Okay, so that is heat is produced. Okay, so that is on the basis of heat, the reactions can be divided into two types of reactions, that is exothermic reaction and endothermic reactions. Okay, so these are two important classification of reaction, that is exothermic reaction and endothermic reaction. So exo means out. Okay, so what does exo means? Exo means out, and endo means in. Okay, clear? So in exothermic reaction, what is seen that heat is produced during the reaction. Okay, that means heat is given out from the reaction. Okay, so heat will be given out from the reaction, that is two reactants are reacting and we are getting a product, as well as heat will be released by the reactants. Okay, so heat is produced during the reaction, but in some reaction you will see that there are two reactants and we are heating the reactants so that the reactions proceed. Okay, so that is we are supplying the heat into the reactants, and here the heat is coming out of the reactant after the reaction starts. Okay, so exo means heat comes out and endo means heat is given to the reactant. Okay, so an example is that we have already seen an example, that is if we have considered this reaction, what we saw, calcium hydroxide plus heat. Okay, so here what it means, the two reactants are reacting and it is giving us a product and also heat is generated. So this is an exothermic reaction. Okay, again if you see that burning of natural gas, so what natural gas contains? Methane. Okay, so CH4, this is the formula for methane. This is the formula for methane. Okay, so while burning we will be needing oxygen that is present in the air. So what will happen? We will get carbon dioxide plus water, as well as when we burn anything. Okay, so when you burn anything, if you burn your wood or burn paper, what we feel that when anything burns, it gives us heat. Okay, so when we will burn methane also, what will be generated? Heat. Okay, so this is also an example of exothermic reaction. Again, if you see any decomposition reaction, suppose we are taking the decomposition reaction of ferrous sulfate. So this is the representation of heat. Okay, the triangle above the arrow. So this is the representation of heat. So what we get? This one plus SO2 plus SO3. Okay, so in this reaction, what we are doing? We are supplying heat to the reactant, that is FeSO4, so that the reaction proceeds. Okay, so this type of reactions we will again discuss while discussing the decomposition reaction. So now we are discussing that on the basis of heat, two types of reactions are possible, that is exothermic reaction or endothermic reaction. Okay, so for a common example, you can see that when you are dissolving any glucon D or any object that is having glucose. Okay, so in your home, generally in the summer days, you generally drink glucon D solution. Okay, so when you are dissolving glucon D on water, what you can see, glucon D in water, what you can see, that when you dissolve glucon D in water, the temperature of the vessel or the utensil where you dissolve glucon D, it drops. Okay, so it becomes cooler. Why? Because the temperature which is present in the surrounding, that is taken by the reaction. Okay, so taken by the reaction where glucon D is dissolving in water. So it is an also example of endothermic reaction. Okay, so this is about exothermic reaction and endothermic reaction. Okay, so now there are two more important reactions which are generally classified as exothermic reactions. Okay, so why it is considered as exothermic reaction, we will be looking at this now. Okay, so one of the important example of exothermic reaction is respiration. Okay, respiration. So generally it is a common belief that respiration is only the process of breathing. Okay, but respiration is not only breathing. Okay, breathing breathing oxygen and giving out carbon dioxide. It is not only a process. It is not the only process of respiration. Okay, so what respiration actually is? Respiration means the food that we are taking. Okay, so it has different types of nutrients. We already know that food contains different types of nutrients. Okay, from that we get carbohydrates. Okay, we get carbohydrates, and the carbohydrates is then broken down. We all know that in our body, these complex food nutrients are broken down to simpler ones. Okay, so carbohydrates are first broken down to glucose. Okay, and then this glucose, it reacts with the oxygen that we are inhaling. Okay, so this glucose reacts with oxygen to give us energy. Okay, so this whole process that the food we are taking, it breaks down to their simpler substances. Suppose here that is glucose, the food that are taking, we get carbohydrate from it, and this carbohydrates break down to glucose, and this glucose combines with the oxygen that we are breathing in. Okay, to give us energy. So this whole process is known as respiration. Okay, so this is the formula of glucose, C6H12O6. Okay, so we all know that heat is a form of energy. Okay, so in exothermic reaction, here we see that the heat is given out of the reaction or heat is produced in the reaction. Okay, so since heat is a form of energy, we can also say that exothermic reaction is the reaction where energy is produced or where energy is given out of the reaction. Okay, so since in this reaction energy is produced, we can say that respiration is an exothermic reaction. Okay, and this is the chemical equation of respiration. So this is an important equation. Okay, important chemical equation for your exam. So I will suggest that you can, if you possible, you to try to memorize it. Okay, and if not, then it is very simple. If you what is happening in this respiration reaction, glucose, that is C6H12O6, is reacting with oxygen to give carbon dioxide, water and energy, And why I am saying to memorize it? Because to balance it, because generally if you try to balance it on your own of your exam, in your exam, you will be confused. So I am trying to look at this. Here we have a pattern that all the except glucose, all the other chemical compounds are balanced by 6. Okay, so this is an important reaction for your exam. And generally a common question is asked that why respiration is called an exothermic reaction. And similarly, decomposition of any organic matter can also be classified as exothermic reaction. Okay, so this is all. In the next class, we will be discussing the other type of chemical reaction, that is decomposition and displacement. Okay, so thank you.